Hello, I am Flash Isaac and you are welcome to my physics class. Today, I shall be taking you through Jamb, past and likely physics questions under waves with detailed solution. One thing will happen at the end of this class. Your confidence when it comes to answering questions under waves in physics will boost dramatically. I promise you. So, this class will be as simple as possible, as detailed as possible, and as interesting as possible. To get the best out of this class, I recommend that you go through my waves video. I recently released a video under waves and it covers everything you need to know so long wave is concerned. If you are watching this video on YouTube, I will share a link to it below. If you are watching outside YouTube, simply search Flash Learners Waves on YouTube or visit flashlearners.com. You will find the class interesting. And by the way, if you've not subscribed to the Flash Learners YouTube channel, do that because we have more videos coming that will blow your mind. And there are already videos released for all your other subjects. Go through them and you'll get the best. The second thing I shall recommend for this class is the Flash Learners Jamb application. The Flash Learners Jamb application is the best and the most advanced app to pass Jamb. A lot of persons who installed the app, they did very well in Jamb. Some even scored above 300. So there are a lot of testimony. When you get the app, you have access to questions and answers, and you can watch my videos from the app. Get one for yourself on Google Play Store, flashlearners.com, or chat me up on WhatsApp to get the link. After activation, it will do you good. Now let us begin the journey. The first question here, as you can see, says, which of these waves can be polarized? Remember, a wave is a disturbance or oscillation that transfers energy through matter or space. Disturbance or oscillation that transfers energy through a medium or space with little or no mass transfer. If you are able to get these four keywords, it means you understand waves. A wave is a disturbance or oscillation. It transfers energy. Now remember, physics is the study of matter in relation to energy. While matter is anything that has mass and occupies space, energy is the ability or capacity to do work. It does not have mass. So energy is referred to as antimatter. Wave, being a disturbance, simply transfers energy. It does not transfer matter. It does not transfer mass. It does not transfer particles. Simply energy. And this transfer of energy can either be through a medium or space. Through a medium means some waves would require a medium, matter or material to pass through. While space means some waves, they don't really need material, medium or matter to propagate or to pass through. For example, sound requires a medium to propagate or to pass through. If I say hello, you are able to hear me due to air. Sound travels in air, water, solids. Without these materials, sound cannot travel. If you remove air from here, anything I'm saying, you will not be able to hear. Now, some waves, they don't need material medium. For example, gamma rays, X-rays, light waves. These ones that need medium to propagate or to pass through, they are referred to as mechanical wave. Waves have certain properties. The first property of wave that will interest you is reflection. Before then, example of waves: light, sound, water. When you disturb water, you see the waves at the top, waves on strings, guitar. All these are examples of waves. So waves reflect. What does reflection mean? If you have a rough or smooth surface, as wave bounce on it or as light bounce on it, it will reflect back immediately, which means when waves encounter obstacles, they can bounce back or change direction. And according to the law of reflection, when a wave reflects on a smooth and shiny surface, when a wave shines on a smooth and shiny surface, it bounces back with the same angle at which it enters the surface. So this is it. Let's say the wave is shining this way. This is referred to as incident ray at an angle theta I, incident angle. The wave will bounce back or reflect with the same angle. This is theta R, reflected angle, and this is the reflected ray. Therefore, the incident angle is equals reflected angle. The angle at which it enters the surface is the same angle at which it bounces off the surface. That is according to the law of reflection. Another interesting property of wave is refraction. Refraction is a process whereby waves change direction as they encounter obstacles. For example, if you have a glass of water and there is a straw here, this medium is air, here is water. As it enters another medium, the wave can bend. So when you observe from outside, you notice that this thing has bent. What has happened? Refraction. And refraction obeys Snell's law, the law of Snell, which says that incident index times sine angle of incident is equals refractive index sine refracted angle. That is Snell's law of refraction. There is another interesting property of wave. That is simply diffraction. This is a process whereby waves cut corners or they bend when they encounter obstacles. And this obstacle must be less than the wavelength of the waves. For example, if this is a tree, I am here, this is your ear. If I say hello, there is a barrier. However, this sound wave will bypass here to reach your ear. That is diffraction. It bends when it comes across obstacle. Or for example, if I shine a torch at night, you notice the rays of the torch, they are being scattered. This is a result of dust particles. So the light tries to bend around the dust particles. But the question comes to mind. If you have a big tree and someone is speaking from this end, this person here will be able to hear. But what if I shine a torch here? Will this person here see it? If the tree is very big, if I shine a torch here, this person here will not see it. Why? It does not mean that light doesn't diffract. It simply means that the wavelength of the light is not enough to cover the tree. Light only diffracts when they encounter obstacles that are less than their wavelength. Pardon? Waves only diffract or diffract successfully, or the rate of diffraction depends on the fact that the obstacle should be less than the wavelength of the wave, or the wave should have a wavelength that is bigger than the obstacle that they come across. Another example of, or another property of wave is interference. Interference is when waves join together. Waves from different source, as this is coming here, this other one is coming here, so they join or they get smaller. That is interference. Interference can be constructive or destructive interference. The conditions for interference are you must have more than one source, and two, the waves must be coherent, meaning they must have the same amplitude, frequency, and they must be in the same phase. If they are not in the same phase, they must have the same phase difference. Then the last one, polarization, which we are particularly interested about, is a phenomenon where wave is made to travel in one plane or in one direction or in a confined direction. Waves can be unpolarized or polarized. Unpolarized waves, they travel in different planes or in different directions. Now, polarized light or polarized waves, they travel in one direction or in one plane. So trying to make unpolarized light or unpolarized wave to be polarized, to travel in one plane, is referred to as polarization. And polarization is the exclusive property of transverse wave. Remember, based on direction of propagation of waves relative to the particles, waves can be transverse or longitudinal waves. Transverse waves are waves that travel at right angle to the direction of the medium. For example, if there's a light goes this way, you see that the medium, particles of the medium is going up and down. Or let's use water wave for example. When you heat water this way, you see the particles, they oscillate, they go up and down. So fine, the wave is going this direction, but the particles are going up and down in the direction of the wave. So this is at 90 degrees. In this case, we say the wave is transverse. On the other hand, we have longitudinal waves. In longitudinal waves, the particles are going to and fro in the direction of the wave. Example, sound waves. If I say hello, the sound is going this way. The air particles are moving to and fro until it gets to your ear or to the listener's ear. So the air particles, they are moving to and fro in the direction of the wave. So while in transverse wave, they move perpendicular or at 90 degrees. Now, polarization only occurs in transverse wave. It is an exclusive property of transverse waves. Now, let's see the question once again. Which of these waves can be polarized? Only transverse waves can be polarized. In other words, we can take this question to be, which of these waves is a transverse wave? A. Sound. B. Water wave at a depth. C. Water wave at the surface. And D. Wave generated from a vibrating strings. Now, sound wave is a longitudinal wave. It cannot be polarized. Wave generated from a vibrating string. Now, this is open-ended. Depending on how the string is vibrated, it can be transverse or longitudinal. For example, when one end of the string is fixed and the other one is being shaked, that wave generated is a longitudinal wave. It will move parallel to the direction of propagation, because longitudinal waves, they move parallel to direction of propagation. So which means this cannot be totally said to be transverse wave. Now look at the example, water wave at the surface. Water waves at the surface are transverse waves. When you disturb water, you plug water, you notice that the waves at the surface, they move perpendicular to the particles of the water, they move perpendicular to the direction of the wave. So this happens mostly at the surface, because when you look at water wave at the depth inside, you shake, you will not be able to get that transverse waves. So in summary, examples of longitudinal waves are sound waves, waves on strings with one end fixed. On the other hand, electromagnetic waves are transverse waves, waves on strings and pipes are transverse wave, water waves are transverse waves. Now, the shortcut for electromagnetic waves is simply Gazulia. Gamma rays, X rays, ultraviolet rays, light rays or light waves, infrared rays and radio waves. These are electromagnetic waves. They don't require material medium. So sound waves cannot be polarized because it is a longitudinal wave. 2. Water wave at a depth is a longitudinal wave because the particles travel in parallel to the direction of the wave when the wave is at the depth of water. But at the surface, the direction of the wave is at right angle or perpendicular to the direction of movement of the particle, which means Water waves can be transverse or longitudinal. At the surface of the water, it is transverse. At a depth, it is longitudinal. Wave generated from a vibrating spring is simply a longitudinal wave. With this, water wave at the surface remains our best option. When the length of a vibrating string is reduced by 1/3, its frequency becomes dash. What is the relationship between frequency and length? Frequency is inversely proportional to length. So let's call this length the original length. The length being reduced by 1/3 simply means the new length is 1/3 of the original length. And this is L/3. This is the new length. So if this new length is used here, this is simply F is proportional to 1/L/3, where this is the reduction by 1/3. This is the same thing as F is proportional to 1 times or 1 divided by L/3. 1 divided by L/3. Changing division sign to multiplication will invert this. So this becomes 1 times 3/L, which gives you 3/L. Therefore, frequency becomes 3 times 1 is proportional to 3 times 1/L. This is what happens. Originally, it is 1/L. Reducing the length by 1/3, frequency becomes 3 times 1/L. This means frequency is now 3 times its former value. So what is the answer to this question? When the length of a vibrating string is reduced by 1/3, its frequency becomes 3 times the former value, or 3 times the original value. Option B is the correct option. The characteristics of a vibration that determines its intensity is simply the frequency. Frequency is what determines the intensity of vibration. Here it says I, coherence, II, same frequency, III, same wavelength, IV, same intensity. Which of the conditions above are necessary to produce interference fringes? Earlier in this video, I explained the properties of waves. Then, under interference, I gave the conditions for interference. I said 1, we must have more than one vibrating source. 2, the waves must be coherent, which means they must have the same frequency wavelength, either in phase or out of phase by the same value. Therefore, coherence, same frequency, and same wavelength are conditions for interference. Option B is the correct option. And the next question says, what type of wave is emitted by a loudspeaker? A loudspeaker. At home or in your music box, you see speaker playing, and you are vibing, right? Now, what are you vibing to? You are vibing to sound, which means the loudspeaker produces sound waves. Now, if sound wave a gamma ray, is it a radio wave? Is it a longitudinal wave? Is it a transverse wave? I have explained this more than once. A perfect example of longitudinal wave is sound wave. When I say hello, the wave moves the air particles to and fro, to and fro. So they are moving parallel to the direction of the waves, not perpendicular. So loudspeaker produce sound waves, and sound waves are longitudinal waves, not transverse waves. And also, take this as an example. Anytime you see gamma ray, radio wave, or any electromagnetic wave, they are simply transverse waves. And water waves at the surface, they are transverse waves. Light waves, transverse waves. Okay? While waves on strings tied at one end, they are longitudinal waves. Water waves at a depth, they are longitudinal waves. Waves on springs can be compressed and expanded. that is compression and refraction, being properties of longitudinal waves. We are given the wave equation y is equals 5 sine 200 pi t minus 0.4 s. We are asked to calculate the wavelength. Now look at something. Anytime you are given the equation for progressive wave or questions like this, what you simply do is to compare to the standard wave equation. This is the standard wave equation. Y is equals a sine theta plus phi minus phi, or plus or minus phi, depending on whether it is at the positive y-axis or along the negative y-axis. Along the positive s-axis rather, or along the negative s-axis. Along the positive s-axis, it is negative, and along the negative s-axis, here is positive. That's why it is plus or minus. Now this is y is equals a sine wt plus ks. This is the phase difference and this is the phase angle. So the phase angle is wt. Let's use minus since we have having minus here. The phase difference is ks. So this and this are the same. From here, you can get another equation, which is y is equals a sine. What is w? W is angular velocity and it is 2 pi f. What is k? K is equals 2 pi over lambda. That is their value, which implies that here can be 2 pi f over lambda. No, 2 pi ft, where here is w, then here is 2 pi over lambda. So with this, you are good to go. You can choose to do some mathematics here. For example, from here, this is frequency. We know that V is equals F lambda. True or false? True. If V is equals F lambda, it simply means that, V is equals F lambda. If V is equals F lambda, it simply means that F will be V over lambda. F will be V over lambda. So from here, Y is equals A sine 2 pi. Instead of F, V over lambda. T minus 2 pi. Here is S. 2 pi S over lambda. Now this is where I'm going to. When you factorize, Y becomes A sine 2 pi over lambda Vt minus 2s. No, Vt minus s. So 2 pi over lambda, 2 pi over lambda, Vt minus s. This one is what is shown in your Jamb syllabus. When you see your Jamb syllabus under waves, you see equation of progressive waves, and they will give you something like this. So this is how they arrived at this equation. But most times, or for calculation, this one alone is enough for you to solve. I am doing this for you to be exposed to every of the equation. So once again, this is it. This is the original equation for progressive wave. Progressive waves are waves that are produced with no restriction. Sound waves, water waves, they are produced with no restriction. They are free. The opposite is standing or stationary wave. Stationary waves are produced with restrictions. When you hold a spring or rope at both ends and you are producing wave, there is restriction in that wave. So that is standing or stationary wave. Now, the first angle is the same thing as Wt. The first difference is the same thing as Ks. And W is 2 pi F. K is 2 pi S over 2 pi over lambda. Then the S remains here. Which means if you know only this one, you should be good to go, because from here you'll be able to arrive here. So with this, you should be able to answer any question under progressive waves. This is something I will do for you. Understand these two formulas. Understand this and this formula. With these two, you'll be able to solve for amplitude, frequency, wavelength, and even velocity, because V is equals F lambda. If you're able to arrive at wavelength and frequency, you'll be able to get velocity. So let's see how to solve questions under progressive wave equation. This is the equation we are given, and this is the standard equation. A is amplitude. What is amplitude? Amplitude is the maximum displacement of wave from mean position or from rest. So if you have this wave, this maximum displacement from rest is the amplitude. Then from here to here is the wavelength. It's the distance from one point to exactly that same point in another wave. So from here to here is one wavelength, from here to here is one wavelength. And if you have here, from here to here is one wavelength. If you are asked to look for amplitude in this wave, you simply say, comparing the equations, amplitude A is equals 5 meter. Simple. You compare y, A is A, sine is sine. So which means 200 pi t is the same thing as 2 pi t when you compare. So this one has pi, this one has pi. So you say 200 pi t is equals 2 pi ft. When you divide both sides by pi t, what happens? Pi t cancels pi t cancels pi t. You are left with 200 is equals 2f. Dividing both sides by 2, f is equals 100 Hz. You solved for frequency. Now, what else? If you compare this and this, 0.4s is the same thing as 2 pi s over lambda. Or you can simply say minus 0.4s is the same thing as 2 pi s over lambda. So dividing both sides by s, this s cancels this s, minus cancels minus, you are left with 0.4 is equals 2 pi over lambda. Lambda is equals 2 pi over 0.4. That is the value of lambda, 2 pi over 0.4. And 2 pi over 0.4 is the same thing as 5 pi. And what is pi? Pi is 3.142. So 5 times 3.142. What does that give you? That should give you 15.7 meter. So in radians, that is the value of pi. So the option is option A. That is the correct option. So we were asked for just wavelength. I use this question to solve for all the possible things you will be asked under progressive wave equation. If you are asked for velocity, velocity is f lambda. V is equals 100 times 15.7 meter hertz. Because frequency is 100 hertz, wavelength is 15.7. So you've gotten the value of frequency. That is it for progressive wave and calculations under waves. Then the next question says, the frequency of the wave in the diagram above is dash. Now what is frequency? Frequency is the number of oscillation per second. Number of oscillation per second. Now, how many oscillations do we have in this wave? We simply have one oscillation because that wave goes to and fro. It is a complete wave, or that wave simply have one wavelength. From here to here is a full wave or a full oscillation. And looking at this wave, it is something like this. Like this. So this is a complete oscillation. And the time it took to complete the oscillation is 4 seconds. The time to complete one oscillation is 4 seconds. And what is that referred to? The time to complete one oscillation is period. Period is equals 4 seconds. And what is frequency? Frequency is 1 over period. That is simply 1 over 4 equals 0.25 seconds. Once again, looking at this wave, that is a complete oscillation. And the time it took to complete the oscillation is simply 4 seconds. And that is simply period. Then period is 4 seconds. Frequency is 1 over period. That is 1 over 4, 0.25 Hz. You can solve it another way. Frequency is number of oscillations over time. Number of oscillations over time. In these waves, how many oscillations do we have? Simply one of oscillation, one complete wave. What time? 4 seconds. That is 1 over 4, which is the same thing as 0.25 Hz. So we've answered the question in different ways. If a sonometer has a fundamental frequency of 450 Hz, what is the frequency of the fifth overtone? What is the frequency of the fifth overtone? The fundamental frequency is equals 450 Hz. Now recall that Fn is equals n plus 1 F naught. So if you are asked for a particular overtone or the particular number of overtone, you simply use this formula. The number of overtone is equals n plus 1 fundamental frequency. This question says, what is the frequency of the fifth overtone? Since we are looking for fifth overtone, it simply means that n is equals 5. So f of the fifth overtone is equals 5 plus 1 times fundamental frequency. So the frequency of the fifth overtone is equals 6 times the fundamental frequency. 6 times 450, that will give you 2700 Hz. So that is the frequency of the fifth overtone. If we are asked for the frequency of the third overtone, n is 3. So 3 here, 3 plus 1, 4 fundamental frequency. The frequency of the 10th overtone is simply 11 times the fundamental frequency. The frequency of the 19th overtone is 20 times the fundamental frequency. I hope this makes a lot of sense to you. And look at this question. It says that the fundamental frequency of a plucked wire under a tension of 400 Newton is 250 Hz. When the frequency is changed to 500 Hz at constant length, what is the tension? Tension on the wire. The fundamental frequency of a plugged wire under tension of 400 Newton is 250 Hz, which means the fundamental frequency, or F1, is equal to 250 Hz. Tension, or force, is equals 400 Newton. So when the frequency is changed to 500 Hz, let's call this F1, let's call this F2 to 500 Hz. Constant, what is the tension? Tension is equals question. Let's call this T2, let's call this T1. So once again, the fundamental frequency of the plucked wire under a tension of 400 Newton is 250 Hz. So let's call the first tension and the first frequency T1 and F1. The frequency is changed to 500 Hz, which means the frequency is increased. So what will happen to the tension? This is more or less a variation question, which means when we increase or reduce frequency, what happens to tension? When we increase or reduce tension, what happens to frequency? Now look at it. Frequency is directly proportional to the square root of tension. Frequency is directly proportional to the square root of tension, which means frequency is equals k square root of tension. Y equals k. We don't solve with proportionality symbol. We simply convert to equality symbol to introduce this. If this is true, it simply means that frequency divided by the square root of tension is constant. So therefore, let's call this frequency F1, let's call this tension T1 is constant. Since constant doesn't change, it also means that the second frequency over the second tension will also be equals constant. Since this is constant and this is constant, therefore this is equals this. So we therefore say that F1 over the square root of T1 is equals F2 over square root of t2. So take note of this formula. Instead of deriving it over and over again, knowing this is just for you to substitute, and you shall be able to answer as many questions as possible. So F1 is 250 over T1 is 400. So square root of 400 is equals F2 is 500 over T2 is question T2. When you cross multiply, you simply have that the square root of T2 is equals 500 times square root of 400 over 250. Now, if you actually choose to break them down from here, it is fine. But if you are somebody who loves to have bulk work, you can simply say that square root of this is the same thing as the square of this. So square cancels square root, then everything here is squared. This should simply give you T2 is equals 500 squared times square root of 400 squared over 250 squared. So solve this from here. You can choose to solve this the best way you wish. You should be able to get 1600 Newton. Which of the following factors will affect the velocity of sound? A. An increase in the loudness of the sound. B. An increase in the pitch of the sound. C. Wind traveling in the same direction of the sound. D. A change in atmospheric pressure at constant temperature. Now, pitch, loudness, atmospheric pressure, they have no effect on sound. Remember, sound is a mechanical wave. It requires material medium to propagate. So air, wind, materials, they are required for air to propagate or to move fast. Therefore, wind traveling in the same direction of the sound will help to affect the velocity of the sound in air. So option C is the correct option. And this one says the pitch of a sound note depends on that. Pitch is simply the position of sound in a musical scale. It simply explains how high or how low a sound is. So pitch of the sound is dependent on the frequency of the wave, while loudness is directly proportional to the square of the amplitude. Looking at this question, the pitch of sound notes will depend on frequency. The next one says, the phenomenon that makes sound persistent when its source has been removed is known as dashed. Now, there is something called the prolonged effect of sound after the source has been removed. That is referred to as reverberation. Reverberation. It says a traveling wave moving from left to right. So a traveling wave moving from left to right has an amplitude of 0.15 meter. So here is amplitude. A is equals 0.15 meter. Frequency is 550 Hz. And the wavelength, lambda, 0.01 meter. The equation describing the wave is this. Now, earlier we solved a question, but in that question we are given the equation of traveling wave and asked to look for certain parameters. But this case, we are given parameters and asked to arrive at the equations. Now take a look at these facts. They will help you solve a lot of questions. First, the equation of traveling wave is equals A sine Wt plus or minus Ks. Y is equals A sine Wt plus or minus Ks, or A sine theta minus phi, which I told you that this is the same thing as Y is equals A sine 2 pi f t plus or minus 2 pi over lambda s, where 2 pi f is angular velocity and k is 2 pi over lambda. Everything here is the phase angle, everything here is the phase difference. Now, it is minus if the wave is moving in the positive s axis, and it is plus if it is moving towards the negative s axis. Now, this question specifies direction. It says the traveling wave is moving from left to right. So if the wave is moving to right, so if they specify direction for you and they say the wave is moving to right, this is what you do. Use this formula, y is equals a sine ks minus wt. So moving to right, use this, it is okay for you. If they are said to left, you use plus here. Once again, if you are given the wave equation and they say moving to right, use a sine ks minus wt. Moving to left, a sine ks plus wt. So take note of this. But if you are just given a wave equation and asked to look for certain parameters, just compare with this general equation, you'll be able to get your answer. So from here, this is the same thing as y is equals a sine 2 pi over lambda s minus 2 pi f t. Y is equals a amplitude is given 0.15 sine 2 pi s lambda. Do we have s? No. Do we have lambda? Yes. That is 0.01. So here is simply 2 over 0.01 pi s minus 2. Do we have f? Yes, 550. So this is 2 times 550 pi t. What we simply did here is to substitute. We substituted the values given. So this is the same thing as y is equals 0.15 sine 2 over 0.01 is 200. So this is 200 pi s minus 1100 pi t. 2 times 550 is 1100. So what next? Y is equals 0.15. We can actually factorize. We can bring out pi and 200. Yes, it's possible. So if here is sine and here is 200 pi, here remains just s, because 200 pi s divided by 200 pi s will be left, minus 1100 divided by 200 is 5.5. Then pi divided by pi cancels, so t will be left here. If you don't understand what we did here, simply do something like this. 200 pi times s, what would that give you? 200 pi s. 200 pi times 5.5t, what would that give you? 1100 pi t. So we did not alter anything. And looking at the options, the correct option is obviously option A. Y is equals 0.15 sine 200 pi, bracket open, s minus 5.5 t, bracket closed. Isn't this interesting? To me, it is an interesting question. How about you? What do you think? This takes us to the next question. The equation of a wave traveling in the horizontal direction is expressed as y is equals 15 sine 2 pi over 5 60t minus s. What is the question? The question says, what is the wavelength? Now, anytime you see questions like this, they require reasoning. They require wisdom. For me, anytime I see question like this, and they've already factorized it, which means they've given this equation of progressive wave in this form that I did here, in a factorized form, I will not agree. I will simply take it back to this form. How do I do this? How do I do that? I'll simply say 15 sine 2 pi over 5 times 6. That is 2 times 6, 12. This is 12 over 5 pi t minus 2 pi s over 5. So I use this to multiply each of the values in the bracket. So this is the wave I am comfortable with. I'm looking at this wave equation, or the normal wave equation, y is equals a sine 2 pi ft minus 2 pi over lambda s. We are looking for wavelength. So out of these two, only here will give us wavelength. So we therefore need to compare these two to get wavelength. Minus 2 pi s over lambda is equals minus 2 pi s over 5. Minus cancels minus, 2 cancels 2, pi cancels pi, s cancels s. So what is basically left is 1 over lambda is equals 1 over 5. So lambda will therefore simply be 5 meter. So this is an interesting question. And from here, you may choose to look for frequency. It is simply comparing these two. If you are looking for frequency, you have 12 over 5 pi t is the same thing as 2 pi ft. Pi cancels pi. 2 here, 6. So you have 6 over 5. T cancels t is equals f. So this is the frequency. It actually makes a lot of sense. And if you are looking for the velocity of the wave, is f lambda. And frequency is 6 over 5. Lambda is 5. So you see, velocity is 6 meters per second. So that is it. Equations or questions under progressive waves are very, very interesting. And I've done my best to make sure I get enough questions from these. The transverse waves can be distinguished from longitudinal waves using the characteristics of dash. A. Diffraction, B. Refraction, C. Reflection, and D. Polarization. Polarization is a unique property or exclusive property of transverse waves. Longitudinal waves cannot undergo polarization. Therefore, to distinguish transverse and longitudinal wave, only polarization can be used. One end of a long wire is fixed, while a vibrator is attached to the other end. When the vibration is energized, the type of waves generated in the wire are: now, wave produced in the wire fixed as one end is a longitudinal wave. And in the process of producing that wave, there is restriction. So when you produce waves with restriction, they are referred to as stationary waves. So what I see there is simply stationary wave and longitudinal wave. That is option A being the correct option. And this question says: 1. Temperature, B. Density of air molecules, C. Pressure, or 3. Pressure, and D. Pitch. Which of the above will affect the velocity of sound in air? The velocity of sound in air is affected by temperature, relative humidity, and density of air molecules, not pressure or pitch. So option A is the correct option. And this one says: which of the following is a characteristic of stationary wave? They are formed by two identical waves traveling in opposite direction. That is option C. When two identical waves are traveling in both the opposite direction, we form a stationary wave. And for this question, it says that if a light wave has a wavelength of 500 nanometer in air, a light wave has a wavelength of 500 nanometer in air, what is the frequency of the wave? Given the speed of light to be 3 times 10 raised to the power of 8 meters per second. So the velocity of light is 3 times 10 raised to the power of 8 meters per second. We are given the wavelength to be 500 nanometer. Then what else? We are asked to look for the frequency. So V is equals F lambda, or V is the same thing as velocity. C is equals F lambda. F is C over lambda. Now we are given lambda in nanometer. We need to change it to meter to get 500 times 10 raised to the power of minus 9 meters. To convert from nanometer to meter, you multiply by 10 raised to the power of minus 9. So this will simply give you 3 times 10 raised to the power of 8 over 500 times 10 raised to the power of minus 9. So this will give you 3 over 500 times 10 raised to the power of 8 minus 9. According to the law of indices, when you have division and the base are the same, you simply add the power. So 8 minus 9, that is 8 plus 9. 8 plus 9, would that give you 17? Yes. So this is 3 over 500 times 10 raised to the power of 17. So 3 over 500 times 10 raised to the power of 17, that should give you 6 times 10 raised to the power of 14. So making option D the correct option. A wave that travels through a stretched string is known as dash. Looking at all the options, the most appropriate is mechanical wave. Stretched string simply means it requires a material medium. So any wave that requires a material medium or a matter to propagate is referred to as mechanical wave. And which of the following is exclusive property of a transverse wave? Polarization is exclusive property of a transverse wave. And the sound of an electric bell dies slowly when air is slowly pumped from the bottle because sound needs a material medium. The fundamental property of a propagating wave, which depends only on the source and not the medium of propagation, is harmonics. Overtone is a term generally applied to higher frequency standing waves, whereas harmonic is reserved for those cases in which the frequency of the overtones are integral multiples of the fundamental of the frequency. So overtones or harmonics are also called resonance. Ladies and gentlemen, physics questions past and likely under waves. This brings us to the end of the class. Feel free to check out the Flashness channel for more videos on physics. I have a dedicated category for physics, all physics topics. Then I have another dedicated category for Jamb. That one only covers Jamb questions and answers, everything concerning Jamb. But the physics playlist covers physics for schools, Jamb, scholarship, whatever you are using physics for. And don't forget, I am making use of the Flashness Jamb application. Install one for yourself and start using. Don't forget to tell your friends about Flashness and subscribe to this channel to get more amazing videos like this. Thank you. I am Plucked.